infinity, y tends to, you understand? But yes, she's right. Something is stretched, something is flattened, is stretched, when what happens? Yes?
Stretches upward when the standard deviation decreases.
When standard deviation decreases, what happens?
It
Stretches upward. Something like that. Okay? So look, you see the standard deviation is a spread, right? So when you say something spread more than the other, so this doesn't spread that much. That is why it's like squeezed in here. But when you say, oh, I want a bigger spread, and I still want to maintain my area 1 under the curve, but you want it to spread across, then it's going to extend, and to maintain that area, this will have to come down. Then it will affect the maximum point, like she said. Because the area still maintains 1. Understand? So that's the main thing. Now, the next thing, does the curve have a line of symmetry? Does it? Yes. And what is our line of symmetry? Say that again. X is equal to mean, not just mean. X is equal to mean. It could be y is equal to something. So you need to state which of the variables responsible for it. Someone asks you for the equation of a line. Don't just write 2. Is it x is equal to 2 or y is equal to 2? You have to be specific to avoid being misquoted. Is this function ever negative? That's the function over there. Is it ever negative? No. Why is that? Are you sure? Why is that? Someone convince me. Because this is one of the properties that makes it a valid PDF, isn't it? The first 2 things we must check. One is what? If you want to check that f of x is a valid distribution and probability density function, what is the first thing you check? Or one of the, it doesn't have to be the first. One of them will be f of x greater or equal to 0. You must check that. Yes?
For all the
Say that again?
For all the values of the
throughout the entire domain. Understand? But what about the second thing? Well, what about less than 1? You said greater than 0. What about the less than 1 part?
Yeah.
Yes? We have to also check that.
Each of the values within the domain each of the values of the probabilities between like the domain has to be between 0 and 1.
Does everybody agree with that? No.
Oh, it can also be 0.
No. There's no less than 1.
It's just greater than equal.
That is for your probability, if you have your probability function. If you are, okay, let me put it, I think you're confusing it. Your P of x is what we said must be within this range. Not your f of x. Understand? Your probability mass function or density function doesn't have to be. One of the probability mass function we did was x over 8. If your random variable takes the value, maybe x is equal to something. Let's see. Okay, this would never be. When we did our continuous random variable, our probability density function could be more than 1. Because it's a cumulative distribution. The idea actually came from your cumulative frequency curve, but there was no time to go through all that. So when you're dealing with the PDF, you are not restricted by less than 1. That's the point I'm trying to make. Understand? But if you are dealing with the discrete random variable, that is when we always try to justify between 0 and 1, not in continuous. Because here we are dealing with the probability density function, not the P of x that we dealt with in the previous one. Do you understand? So please go back to those notes and check Don't make. I intentionally put that question to you just to be sure that you are not mixing them up. And you all almost passed until you thought, okay, oh, that's true. It should be less than 1. No, it shouldn't be. Okay? So the question is, that's one thing we have to check. The second thing we have to check is that what? What? The area under the curve is 1. What does that mean? The integral, right? Throughout the entire domain must be 1. So integral of f of x dx must be 1. So I mean, when you integrate this within negative and positive infinity, because there's no boundary, you can see the arrow. The arrow means it continues indefinitely both sides. So between negative and positive infinity, the integral is 1. Understand? So those are the two things. So the question is, we know that it must be greater than or equal to 0. How can we justify that this is greater than or equal to 0? To do the integral is beyond some of the things you can do here. Okay? We have some interesting results. I think they were given for the proof. Okay, maybe not here. Never mind. Yes? How can we justify that this is greater than? Exponential anything, whether positive or negative, is never negative. E to power anything is never negative. Our exponential function, at least you've done that before. Our exponential function is always like this. This is your x-axis, which means y is negative is below here. It's always in this form. So exponential function is not negative. So if exponential function is not negative, last time I checked, these are not negative too. So it will never be negative. Okay? Why is this so important? So the question is, why is it so important? If this is a PDF, it will never be negative. So the first part of the question is not relating it to being the probability density function. The first part of the question is looking at this f of x. Can it be negative? Okay? Oh, it can never be negative because of those reasons we have said. Exponential function cannot be negative, so the product of that and the positive constant cannot be negative. Now, why is this important? Oh, it justifies the fact that this is a PDF, and the probability density function can never be negative. So that is why that is very important. Discuss the behavior of the normal curve as x tends towards that. What is the behavior? As x tends toward positive or negative infinity, what do you notice about the normal curve?
It approaches
0. It
0.
approaches y equals 0. Just say 0. So what does that tell you about y is equal to 0 or the x-axis? With respect to the normal curve, what is the relation between this and this curve? There is a term that we have learned. It's the asymptote. Again, I will have given you no points. What asymptote? Horizontal asymptote. Stop saying 0 asymptote. Come on, guys. If your answer is ambiguous, which means it could be misinterpreted the other way around, then it's not a valid answer. So you have to use all the words yourself. Okay? Oh, it approaches 0. You mean it approaches x equal to 0? That means you're assuming that I know, so I should supply the final letter for you. No. You supply everything. That's how you can be convincing. Understand? So definitely, that is the asymptote. Let's see. What do you think happens to the area under the curve as that changes? When you change your mean and your variance, what happens to the area under the curve? What do you notice? Let's change the mean. What happens to the area under the curve? It's the same. What do you think for this one also?
Also the same.
It's the same. That's why it's spreading, because it has to contain it. Alright? But we'll leave the other part because of the calculus. Use calculus to find this turning point. Maybe we can try. Let's see. To find turning point, what do we do?
Draw a sign diagram.
What?
Draw a sign diagram.
Oh. You differentiate first. Okay? Differentiate first. I hope we have time. But maybe we shouldn't bother. I can send you the solution when I work it out. But basically, our f of x is equal to 1 over sigma root 2 pi exponential minus x minus mu divided by sigma all squared. Okay? To find the turning point, you differentiate, isn't it? So this is a constant, it's going to stay. To differentiate an exponential function, d dx of exponential, maybe f of x, is what? F prime of x, come on, okay, shush. Yes? Exponential f of x. So similarly, now if you look at this, the f of x in this case is minus 1 over 2 x minus mu over sigma all squared, isn't it? So let's do f prime of that. Oh, this is f, this is f. Let's call this g. Okay? So definitely it's going to be 1 over 2 times that, right? So now this is x minus mu over sigma multiplied by the derivative of the bracket. The bracket, sorry, I'm not writing this in a detailed form because I don't think we should waste so much time on it. The bracket is like this: x over sigma minus mu over sigma. Do you agree? That's the bracket. So when you differentiate the bracket, what do you get? 1 over sigma. So basically, this is simply minus 1 over sigma x minus mu divided by sigma as well. Does that make sense? So this is going to be times 1 over, minus 1 over sigma. Let me know if I've made any mistake. Then the same thing, right? That'll be the first derivative. The derivative will be this constant. Then we differentiate this function of x. To differentiate this function of x, you copy and paste. Then you multiply by derivative of the power. Derivative of the power is this. Derivative of this one. Okay? Do I do it again? Raise your hand if you want me to quickly show this again. Everybody's good? Alright. So quickly, at the turning point, I don't want to waste time, sorry. This is equal to 0. If you equate all this to be 0, you can divide by the non-negative, right? Which is which one? Which part? The exponential part. So basically you're having 1 over sigma squared 2 pi in the square root, then x minus, no, there's a minus here. All this f of x, blah, 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 is equal to 0. This can be divided. In fact, this can also be divided. Understand? So, if you do that, you get, no, actually, what if our variance is 0? What if it doesn't vary? So let's not assume that is 0. That is non-zero. But we can divide this. We can divide this one. If you divide this, then you are left with minus bracket x minus mu divided by that is equal to 0. Do you agree? Yes? Then we can cross multiply. And actually we didn't divide this. Then that's fine. So minus bracket x minus mu is equal to 0. What do you notice? X is equal to mu. Which is why whenever we draw a normal curve, at this turning point, x is always equal to mu. Does that make sense? And if you do the second derivative, you can find a point of inflection. Second derivative will be when we differentiate this again and equate it to 0. At the point of inflection, second derivative is equal to 0, right? If you do that, you are going to notice the result that I've given you. Let me project that. Because of our time, I don't want us to go into that. If you do that, you are going to notice at the point of inflection, there are 2 points of inflection, and in each case, you have this. Hello? At the point of inflection, this is where the curvature of the curve changes, right? From here, then it's changing direction. Maybe it's going up, maybe it's not going up, it's just going sideways. We don't know, we don't care. But at least the direction changes here. That's your point of inflection. Calculus now. Understand that? So, which is why I gave you, oh, I haven't given you, okay, I thought I did. Can you pass to the back? Brandy, this is for your table, quickly. Take 3, pass to the next table. Do you have enough?
We need one more.
One more for Krista. Okay, Krista, get from them. So if you look at that, because of our time, I go through with a summary. Please look at the board. It's also in your paper. Let's just quickly explain this. We have seen the first one. It is non-negative. The area under the curve will be 1. We didn't show that, but you can try. The area under the curve will be 1. From negative infinity to positive infinity, you probably need a result that you haven't learned for your level, which is why it is not going to be required. Okay, I'm happy to send you the solution later. The curve is symmetrical about the vertical line. We just realized that also. At the maximum point, x is mu. Okay, so that's automatically, and since it's a symmetrical shape, right, and the maximum point is x equal to mu, then the line of symmetry, or the axis of symmetry, is x is equal to mu, which is the mean, the median, and also the mode. Understand? The mean will be calculated using expectation later. Okay, but you realize you get mu as expected. Now the maximum occurs as the maximum. So when you substitute back, when x is equal to mu in the f, this is what you get, and it's trivial from the equation. If x is equal to mu, that's it. Mu minus mu is 0. Everything here is 0. Exponential 0 is what? 1, leaving behind it. That's where you get that. Okay? So the conclusion from here, because it doesn't say, unlike when I was talking about the, what's it called now? The point of inflection. How many point of inflection can we see there? 2. So it's possible when you do your calculus and all that, maybe there are 2 turning points, something like that. But there's only 1 turning point, which tells you the normal distribution is a unimodal distribution. And of course, you know what that means. What does that mean, Karen? 3 seconds. If a distribution is a unimodal distribution, what does that mean? 2 seconds. 1 second. No food for you today. Clarissa, what does that mean? It only has 1 mode. Talked about that before. If it has 2 modes, what do we call such distribution? Bimodal distribution. Okay? And the syllabus expects you to get familiar with that also. What if you have 2 modes? Okay? Alright, so quickly. So the mean, median, and mode are the same. X-axis is the asymptote. These are the things you have talked about. The symmetry, the inflection occurs at these 2 points. So if you substitute, this is what you get. And this is what the picture will look like. The standard deviation, if you look at it, now look at this. This is where it gets interesting. The standard deviation, as expected, is the spread, isn't it? It's responsible for how does it spread. If it doesn't spread at all, it's going to be that tiny little guy, the skinny guy. Oh my God, you need to see my picture in high school days. Oh my God, I was so skinny. I think my standard deviation must have been 0.2 if I was a normal curve. So if the standard deviation is so small, it's going to be like that. Standard deviation is so big, it means it's spread, and it's going to spread out. So the spreading is with respect or relative to the axis of symmetry. Because that's to be symmetric, right? So whatever happens here must happen here. Spreading here is like, say, plus, then minus, like that. Because remember, these are x values, right? So the same distance. So take this as the center, of course, which is what it is, plus mu, plus sigma, sorry, then minus sigma here. you will notice as time goes on, you have plus 2 sigma, plus 2 sigma, minus 2 sigma. So this is like a mirror for every other point that you get here. Am I making sense? So quickly, then I put just the notation. So this is what it will look like. Up to, I found this picture up to 4 sigma, so I thought I'd put it for you. Yes, yes, yes. Does it make sense? And this will be needed in calculating probability. Okay? But for now, this is what I want us to do. I have a 2-page worksheet here. I want you to try page 1 now. The first question says match. Okay, maybe to make it fast, I just hand it over. Just page 1. Look at this picture and just draw a line to match which of the distribution they represent. You need the PDF, Mr. PDF? There you go, Mr. PDF.
You also sent this one.
I thought I did. I did not? Oh, okay. Sorry. You're not welcome. That's why I'm going to be teasing him henceforth. So match them. So we, based on the information, are you done with the first page? That should be easy, isn't it? Now look at the second. You have the mean. What is the first thing you draw for number 2? It says mean is 25. Which line of symmetry? Okay, so the first thing should be your line of symmetry. Make it a dotted line, please, not a thick line, okay? You draw your line of symmetry so you know where it is symmetrical. Everything should be on the same axis as provided. So you can draw the 3 lines of symmetry. Then the spread will determine something as well. So you figure that out. Mr. Brandon, that's what we're doing. Check the second page as well. Once you finish the first page. Favorite OCD. No one can pick your blame when it comes to OCD. Definitely. Just in case that is a signal. Maybe it's a signal for food. It's been a long time I taught you guys something. I've been a bad teacher. My wife was like, oh, what is that? Because she heard your voice and she also heard Nigerian music. What is that? Like, oh, that's my class today. Done? First 9, June 25. Yay. Wait, isn't that close to Karen's birthday? No. You're June 7? 5. Or 2 days after me. Okay. You guys won't be here anyway. June 25.
Wait, no, I think we still have to be in Macau. Yeah, we still have to be in Macau for like the school ceremony.
You still be in Macau?
Yeah, we'll still be in Macau.
You what? Fast and Furious 9. I'm a fan, okay?
Okay.
Don't mock me.
Okay.
They're still making new ones?
Yeah, Fast 9. We'll do Fast 10, 11. It's like iPhone.
Oh.
There's always a story, there's always a new bad guy, you know, and there's always a way to entertain us. I love it. So I'm gonna go around to check your normal curves, and if it is not as beautiful as Ethan's, you're in trouble, because it seems to be drawing something cool. Oh my God, it's been OCD. Nakita, you have to watch your back.
Best friend.
Someone is winning OCD game. You know, the way you just spoke now, you look like those kindy babies in art class complaining about their color pencils. Stop touching our iPad.
Is this?
Mr. Brandy, you're blocking our camera. Get out.
Hello.
Hi.
imagine 10 years later, one day I visit the video on March 6th.
Exactly. You're like, oh, 10-year challenge. This was me 10 years
On
ago.
March 5th.
Maybe there will be a little branding. Who knows?